So I'm working on one of the projects, and the project is using Django plus GraphQL on the backend and Next.js on the front end. And the issue with this project is that once it gets like too many users using the application, it gets very slow. And by too many users, I mean only 10 users. Like if it can get only 10 users to use the application, it can get unusable. And the time it takes, like it can take 10 minutes just to respond to a single request. That's how bad it can get. Recently, we added some resources on the server to be able to cope up with the situation and to be able to serve our client better. But I wanted to dig in a little deeper and identify the root cause of the issue. Now, I was able to have a dramatic impact on the application by using AI. And in this video, I'm going to share with you the process or the exact cheat sheet you can copy to be able to have the same results on your application. So stay tuned. All right. So as you can see over here, we were doing 15 requests initially. And after working on the application, I was able to reduce it to 5 requests. And then I was able to also reduce that further to just 2 requests. So what was happening is that when when the client was loading one page, one front end page, it was sending 15 requests. And after working on it on the back end, I was able to reduce that into 5 requests. And then working on it further on the front end, I was able to reduce it to finally 2 requests. And then you can see the visit span, I was able to reduce it from 5,549 milliseconds to just 235 milliseconds. And then SQL queries, I was able to reduce it from 1,345. Imagine just one page loading, we were having 1,000 SQL queries being fired by just loading one single page. And it was taking a total of like 7,000 of time just to fetch data from the database. And then from 1,000 SQL queries, I was able to reduce it to just 8 SQL queries and just to 103 SQL time. And also the total response by as well dramatically reduced to just 1,000 to just 11,620. Just to give you a background, I've said that we were using GraphQL. Now, one of the issues with GraphQL is that it's famous GraphQL N+1 problem. Now, this N+1 problem was it is the one that is causing the main root issues in our application. Like for every record we are fetching, we are doing another fetch for that record, right? So for example, just to give you an example, let's say we have an employees table and each employee is related to the records they have, right? Like the documents, okay? Let's say documents. So when you fetch 10 employees, what happens is that for each employee, we are doing a call to fetch the document. So we fetch employee number one, we make a fetch to call the document. Employee number two, another call for the document. Employee number three, another call for the document. And you can see that this can add up as like if you are calling 20 employees, you are doing like 21 requests to the database. And this is where this high number of SQL queries was coming in from. So this was the main root issue. The other issue was related to the front end where we could basically cache the data and do some other stuff, reduce unnecessary calls, etc. So this is where I was able to like just have reduce it further to just 2 requests. Now, before you dive in and you tell your AI, hey, make this application faster, this is not how it works. You want to build observability into the process first. So you want to know what requests are being sent. Now, before I started working on application, I was just seeing like a GraphQL endpoint was hit with a 200 OK. Like that's it. I didn't know what query we were running, which mutation notice, how much that was being sent, how much data was being received, how much time it was taking, etc. So you want to know the body and what exactly you're working with, right? What query, what mutation you're working with in GraphQL. In the case of REST APIs, I mean, this will be much more simpler when logging. But in GraphQL, you need to like get the query name and stuff. And then you want to know that what requests and how many of them are being sent to the backend. So like one page can send multiple requests to the backend. So in our case, we were sending 15 requests, and then which I was able to like have it just to two requests, right? You want to know the time taken to process the requests. You want to know where the time is being used. So a request is being sent. That's fine. It's taking this much time. But then it might be doing multiple queries, right? So you want to be able to like track down and know which query is being made, which function is being called, how much time is taking while processing the function, how much time it's taking while you know processing the query, and you want to get all this data and log it in so that you have a better observability on what's going on in your application. And finally, when you're working with AI, you want the AI to know where to find both the repos. So it's able to have a better observability into the front end and the backend code, right? And then from there, it will also be able to like tell you, of course, you need to use your own mind as well. You need to use your own brain in this because it's a business decision on what things you want to cache, what are the unnecessary requests that are being sent, where is like which data is not being used, and you are fetching it from the backend. So based on all this observability and all this, you give to the AI, and plus you use your brain, you'll be able to like reduce much time with just a day or two for one request. You can just sit and you can just work on one page at a time, and you'll be able to like you know if you are doing a proper work and you're reviewing it thoroughly, like 1 day or 2 days are enough just to have latency reduced dramatically for a replication using AI. So if you found this video to be insightful, please hit the like button, share with your friends, and let me know in the comment section below what you're struggling with, what issues you're facing. I will be happy to help you. Until next time, see ya.